I'll watch it sometimes.
So, is it then our rule that to get something to go in a circle, which way do we need to apply a force?
Inward.
Inward and toward the center. Okay? That's the rule. I feel good about that. You guys feel okay about that?
Yeah.
Okay, so I want you to watch this. Okay? This is a rubber stopper on the end of a string. It is a rubber stopper on the end of a string. Okay? Can you see it going around?
I do.
Yeah.
Now, because I'm a trained professional,
This is the conversation started because I asked him about your chakra.
because I'm a trained professional,
Is he too?
yes, it looks good. I am moving this at a constant speed. Can you see the fact that the speed is constant?
Yeah.
Yes.
Okay, I would like to know, is it accelerating? Check your neighbor now.
No.
Is it accelerating? Check your neighbor now.
Is it accelerating?
You're right.
Maybe it's accelerating.
Alright. Let's vote. Okay? Let's vote. I would like to know, is it accelerating? If you think it is accelerating, put up your right hand. If you think it's not accelerating, put up your left hand. Are you ready? 3, 2, 1, vote.
I think you got your left and right.
Oh, if you think it's not accelerating, put up like.
Your right hand or my left hand?
We just say if you think it's accelerating, put up your hand.
Y'all know left hand, right? It's the L.
I don't like it. He really needs to count the numbers. I mean, it's like,
It's not a majority rule. It's like, well, Beth said no, so therefore it's not. Lizzie, what do you think? Accelerating or not?
No,
She says no. Tell me why not.
because it's a constant speed, so the forces are balanced.
Okay, does that seem very reasonable? The speed is constant, not accelerating.
Yeah.
That seems like a great way to go. Would someone like to suggest something or either support that or refute it with a different statement? Go ahead. Cole.
It's going in a circle, so it's changing direction, so it has to be accelerating. Can you explain that?
whoa,
I agree.
I agree.
All right, hold on. One at a time.
He said like, it's going like this, change the direction.
All right, so Brendan made a hand gesture. He says, look, we know this is speeding up, this is slowing down, and we saw the other day that this is,
Change the direction.
and this is the acceleration arrow.
Yep.
Okay. Caitlin, where were you on this? You had a comment?
Oh, I think it is accelerating because if you want something to go in a circle, the forces have to be unbalanced. Otherwise, it goes in a straight line. Because one of Newton's laws was how it moves in a straight line.
So she says, look, man, according to Newton, an object in motion will stay in motion in a straight line at a constant speed if the forces are balanced. But if it's going in a circle, that must mean that forces are unbalanced. And if forces are unbalanced, you have acceleration. Now, I was thinking about it, what Cole said was interesting. He says, look, if our acceleration understanding is a change in velocity, what does velocity tell us? Velocity tells us two things, right? It tells us both.
And direction.
So, up until now,
Are we writing this down?
what's that?
Are we supposed to write this down?
Oh, I would, but you can do what you want, man.
Well, I'm gonna. I don't mind writing it. Just asking if we're supposed to.
My thought, I was building off what Cole said. He says, look, velocity tells you two things. Not only the speed, that's the how fast, but also in what direction. Changing the speed would be speeding up or slowing down. We understand those as acceleration, but what if we change the direction part? Is a change in direction a change in velocity? And is a change in velocity an acceleration?
Yes.
It is, right? So here's what I want you to do. Ready?
Whoa.
Almost
That was a really nice circle,
This is
by the
rude,
way.
because you know I can't cross this.
That was almost perfect.
Almost.
Good enough for government work.
Good enough for what?
Government
Not
work.
good enough for science.
Government work?
So if you were to look at a top-down view, if you were to look at a top-down view of this stopper going around the circle, and we looked at it in 4 different moments in time,
Are they drooling?
They're fixing the elevator.
What's happening? We're I would like you to draw acceleration and velocity arrows on each of these dots. Well, I drew boxes, but on each of these, draw acceleration and velocity arrows. Do that right now. Probably one of the worst circles I've ever seen. Trying, I don't know.
So do I.
You done? Draw acceleration and velocity arrows, please.
So we're
Is
drawing
it
off the
accelerating
box.
in
Yes,
the middle?
So is it counterclockwise or counterclockwise?
But the velocity is like velocity.
So acceleration is.
Mr. Pettit,
also
did you
say-
pick
I wanna be like one of those.
Yeah, I really graded them and not put them in the grade.
Wait, so I like already did that.
Oh, no, you can get yours.
Yeah, oh, yeah. Did I get all 3?
Over D1, so not like number 2.
All right, here we go.
Is velocity the slope of the
I've always wanted to
instantaneous velocity, yeah.
Yeah, it's gonna cost you.
Are we gonna do that?
So, we're doing it right now. If you had to tell me, now, I'm gonna draw mine so it's going counterclockwise. Which way do I
I
draw
can't whistle at all.
the velocity arrow here? I want mine to be going counterclockwise. Which way do I draw the velocity arrow?
Tangent of the.
Yeah.
Pointing
Wait, which way is this one?
To the left.
Like,
That way.
No, to the right.
Which way is it going?
Oh, wow.
Clockwise?
This way.
Wait, which way do you want it to go?
They just said.
Is it going
Clockwise.
clockwise?
To the right, to the right.
Clockwise. You want to go clockwise?
Alright,
Go that counterclockwise.
A lot of those.
I thought we were going counterclockwise.
So other way.
Oh, man.
That's what I said.
The same place you did.
How's that?
Nice.
Look good? Or no?
Very
Yeah?
nice arrow.
Okay. What about this one here?
Straight line.
To the left.
and my wrist.
Is that the left?
It'd be like kinda on the.
Yeah, it's like the left diagonally. Yeah.
Yeah, I remember that.
Yeah.
Yeah, like I was gonna say.
And then next one maybe like kinda down.
That was a little funny. I was a little bit traumatized. Like,
Yeah. And then down to the
I
right.
was. That's smart. They're like gossip all the time. They're like told their pictures.
All right, gentlemen, reset please. Tell me about the velocity, tell me about the acceleration arrows.
They're going towards the circle. Or towards the
Inwards and towards.
How's that look?
Yeah.
Is that cool? So we have our acceleration, our velocity. This is part of our, it's called the central force model.
Oh, was that great?
So far, so good?
Yeah.
Now, here's a piece of information.
Colors are big, though.
Here's a piece of information you may or may not know. As I spin this around, okay, do you notice that it's repeating the same pattern over and over and over and over and over?
Like the exact same color.
What do we call,
Red and green.
what do we call the time it takes for an object to repeat a pattern? It's a physics word. A cycle is the actual pattern repeating. What's the time it takes? Revolution is how far it goes.
Wait, I feel like I know this word.
Resolution.
I could be talking about
Instantaneous.
Revolvation.
The revolvation? No, I don't think it's the revolvation.
That's like what it is for like.
Era.
So rotations per time, that would give you like an angular speed of some sort. The time it takes for an object to repeat a pattern is called the period.
Oh.
I heard it.
So you just, then, why can't you just say, yes?
It's not my style, man.
Yeah, I know, but then it can be
I think arc is.
I just like.
It can be on spring break, that's okay. What's on
Some
spring
of my
break?
friends are like, oh, I'm in.
Hey, you said
We're
it.
not going.
I'm not to say that. I'd be like,
Her Wait, are you going to work on spring break?
Gentlemen, ladies, I would love if you limited your conversations that weren't about this to 0. I want to find the speed of this object. What's our conceptual framework for speed?
Slow.
It can be, but in general, does that make sense to you?
Distance over time.
Like in your car, what does your car tell you in terms of the units of your speedometer?
miles per hour.
It's miles per hour. That's miles is the distance divided by the time. Okay? If you are going around a circle,
My car still says
if you're going around a circle, what do we call the distance around a circle?
no. Circumference.
Oh.
That's awkward.
Sorry. That's a little awkward.
First off, it's not even
Parameter.
What is
Parameter.
So
No, that says DIST, distance over time.
Oh,
It's not
Wow, I
about
thought it was
the
a mall city.
She thought it was D times ST.
I thought it was the
Yeah. I can't.
That's supposed to be an
That makes so
R.
much sense.
Oh god. What's your
Oh. Thanks for serving.
He's zooming in on it so people can read.
Still looks like
So
that.
it's
Yeah.
a D
Yeah, you should have made your
folder.
this
These
base
are
of your
my
eye
favorite.
level.
Is this helping?
Not really.
So the circumference divided by the
Perimeter.
Oh.
the distance, the circumference divided by the period. This is how you, in general, can calculate the speed of an object that's keep going around a circle. So you will need this expression for that. Circumference you can calculate by 2 pi r, and we use a capital T for the period.
2 pi r over t.
So in general, if you want to find the speed of an object, you just do the distance it went divided by the time it took to do it. Okay? But specifically for an object that keeps going around a circle, this is the mathematical framework for it. Okay? All right.
Why isn't the period 2 pi?
It's not a sine function.
The velocity would equal the
The period is the time it takes for an object to repeat its
2
pattern.
pi. If it was 2 pi, then the velocity would
Then
be
it'd just be the radius.
The speed is the radius. It's fine. Okay.
I don't care.
The 2 pi's would
All the
cancel.
dumb stuff.
That is really advanced.
No, they have a junior.
Yeah, they do it. Oh, guys, I'm
I'm
sorry.
not
What are you thinking? Earth
So many
science.
people. That was a really.
Why are you taking earth science?
Can you see this stopper?
Yeah, yeah.
That's a dumb
All right.
impression.
Is it going around in a circle?
Yeah.
Maybe.
All
I
right.
mean, we can't
That
see
was
the
really
top.
hurtful.
Well, you can see it from the side.
Here's what I'd like you to do. I want you to take a quick mental snapshot of it. Ready? 3, 2, 1. Click, 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 click. Did you get a good mental snapshot of it?
Yeah, that was really
Okay. I'm going to draw it real fast.
Okay.
Yeah.
So at a moment in time, okay, and it's going around a circle.
Wait, that line is so straight. No, he's such a good artist. You should go to art school. You could be like, I miss this.
You know what song I was
On this dot, I would like you to draw and label the forces on the stopper, but you have to use
You have to use the agent on object notation. What that means is that you have to say that what is pulling on what. Now, obviously, it's the stopper is the object. But when we name forces, don't forget we name the physical object that's doing the pushing and the pulling, right? So draw and label a force diagram for the stopper at the moment that I draw. Okay?
Oh, that is there.
Yes, please.
Mr. Patton, what college did you go to?
I did both my degrees at Wayne State.
Is there like air resistance or anything?
No, we don't need it today.
Wait, so is the string being applying a force, that's like to the angle and then the earth, and then.
I thought we were away from
Yeah.
that. I thought we were saying that.
Let's use the agent object notation so we can all.
It'd be fun. It'd be a therapist.
I don't know, I just wanna like
We'll just-
go in.